Welcome to Mrs. Neller's notes for her double block algebra class. These are the notes for 13.4 entitled Finding Probabilities of Compound Events. And today we're going to find the probability of a compound event. And a compound event is when you're combining two or more events using the word and or. And we're going to talk about what that means in a moment. But it's like when you're reaching into a candy dish and you're trying to find a blue M&M and a red M&M, or you're trying to find a blue one and a green one. Or you could say, I want an orange one or a yellow one. So that's what it means by and or. And we actually have to talk about mutually exclusive and then overlapping events, because that's the different ways that we can have compound events. And mutually exclusive events are where you have no common outcomes. So a good example here would be when you're rolling a die, which remember is just one of the two in a set of dice. So you're going to roll a die. And let's say that you want to roll a 3, or you want to roll an even number. Okay, I'm going to put the word or here because that's our vocabulary word that links the two of these events. Now on the die, we're going to say that there's numbers 1 through 6 because it's a standard die. And so if you want to roll a 3, there's one way that you could do that. You could actually get the number 3. If you want to roll an even number, you could roll a 2 or a 4 or a 6. So there's 3 options there. So we're going to use this equation here for finding the probability of A or B happening. So in this case, A would be rolling a 3 and B would be rolling an even number. Then you're going to find the probability of the first event and the probability of the second event, and then you're going to add the two together. So for the probability of rolling the number 3, we've got 1 out of 6. And for the probability of rolling an even number, we have 3 out of 6. So again, we already have the common denominators, so when we add them, we get 4 out of 6. And then we do want to reduce that, so we have 2 out of 3 for our final probability there. Okay, next we need to look at overlapping events. And I'll leave the equation up there for the mutually exclusive events. I'll leave that there so you can see the difference. Down below here is the equation that we're going to use for the overlapping events. So you can already see that it's a little bit different. We're going to find the probability of the first event, just like we did, and the probability of the second event, and we're still going to add them together, but then we're going to subtract the overlapping part. So let's say again that we want to roll a die, so that's going to be our event, and we're going to assume that it's a standard 6-sided die. And let's say this time we want to roll an odd number, or we want to roll a prime number. Now remember, prime numbers are numbers that have factors of 1 and themselves. So on our die, we have to remember we've got 1, 2, 3, 4, 5, and 6. Whoops, I'm speaking and writing at the same time. 1, 2, 3, 4, 5, 6. So sometimes it's good to list these out so you can see how many numbers are actually even or odd or prime or not prime. So our odd numbers, we would have 1, 3, and 5. And then, let's see, I'll underline them with a little red. These are our odd numbers, 1, 3, and 5. And then our prime numbers are going to be numbers that only have multiples of 1 and themselves. Now 1 technically is not a prime number, but 2 is, and 3 is. 4 is not, because 2 times 2 is 4. 5 is. 6 is not, because 2 times 3 is 6. So we have 3 of each, okay? And you can already see just by the underlining I have some overlapping here. So for my odd numbers, I had 1, and then 3 and 5 are going to go in the middle here because they overlap. And then my prime numbers, I had 2, but then I also had 3 and 5 because they got underlined twice here. So you can see that we have 2 numbers that are overlapping. Okay, so the probability of rolling an odd number, we did have 3 odd numbers altogether out of the 6. And for the prime numbers, we did have 3 of them. We had 3 out of 6. But then we have to subtract how many were both odd and prime, and that was 2, the 3 and the 5. And again, those are the ones that got underlined twice here. So I'm going to subtract the 2 out of 6. So 3 out of 6 and 3 out of 6, that's 6 out of 6, minus 2, that's 4 out of 6. And again, we do want to reduce that. So if I reduce it all the way down, my final answer will be 2/3. So there's a 2/3 probability that I will roll an odd number or a prime number. Okay, so let's take a look at a couple examples here. So for our first example, you're going to roll a die, and anytime you see that, you're going to assume that it's a standard 6-sided die. And we're going to find the probability that you roll a 2 or an odd number. So again, if you want to, you can write down the numbers 1, 2, 3, 4, 5, and 6, because those are the numbers that are going to be on a standard 6-sided die. And there's only one way that you can roll a 2, so that's 1 out of the 6. Now this says or, so we're going to add, and we're going to add our odd numbers, which are 1 and 3 and 5. So there's 3 out of 6. Now notice that the 2 and then the 1, 3, and 5, they don't overlap. 2 is not an odd number. So we don't have to worry about subtracting anything here. We can just add them up. So we'll have 4 out of 6, which is 2/3. Now, for those previous 2 examples, the other answers were also 2/3, and this answer is 2/3. We won't always get the answer to be 2/3. That's just coincidence. Okay, for example 2 here, we're going to roll a die again, and we're going to find the probability that you roll an even number or a prime number. So again, if you want to list out the numbers, that can be helpful. And then first we're going to find the probability that you roll an even number. So I have 2, 4, and 6. Those are my even numbers. So there's 3 out of 6 that are even. And then I'm going to add the probability of rolling a prime number. So my prime numbers, let's see, number 1 is not a prime number, but 2 is a prime number, 3 is a prime number, 4 is not, but 5 is. So again, I have 3 out of 6. And then there was one that is an overlap. 2 is both an even number and a prime number. So then I have to subtract 1 out of 6. So 3 plus 3 is 6, minus 1 is 5 out of 6. This will be my final answer. Okay. So the next concept that we have to talk about is an independent or a dependent event. Now, an independent event is the occurrence of one event that has no effect on the occurrence of the other event. And it's really important that you remember that this means with replacement. So I have an example here. This is where you're going to choose a blue marble from the bag, replace it, and then choose a green marble from the bag. So this way you have the same amount every time that you're choosing from. So you can take, reach into the candy dish and choose an M&M, and then decide, oh, I don't want that one, and you put it back, and then you choose a different one. And while that's not healthy, you're still replacing the M&M, so that way you have the same amount to choose from each time. And this equation here is kind of like the equation that we did for our problem of the day. So you would have seen that in class. So we'll talk more about this equation in class. But let's just say that you were choosing a blue marble and maybe there were 4 out of the 24 marbles that were blue. And then you were also trying to choose a red marble. So let's say that there are 6 out of 24 that are going to be red. So then when you multiply those and reduce, you end up getting 1 out of 24 for your final answer. Okay, but we'll talk more about that when we get to class and you see the problem of the day. But just remember that an independent event means that the events are independent. They have no effect on each other, and that's because you're replacing whatever you're choosing. If it's the little Scrabble tiles from a bag, or marbles, or M&Ms, or socks from a drawer, whatever. You're choosing one, putting it back, and then choosing again. Okay. A dependent event then is different because there is no replacement. So here, the occurrence of one event does affect the occurrence of the other. So this would be where you choose a marble from a bag, you hang on to it, and then you choose another marble from the bag. Or you take a red M&M from the dish and you eat it, and then you choose a blue M&M from the dish. So this means that the total amount that you have to choose from is going to go down every single time. So let's say, like before, you're choosing M&Ms. Let's say you've got 4 out of the 24 that are blue, and you choose a blue one and you eat it. So then you're going to choose a different color. You're going to choose a red one. And so there's 6 red ones, but now since you ate one from before, since you didn't replace it, now there's less to choose from. So your denominator is 1 smaller. Okay? So that's going to change your number then. That's going to change your final product here when you multiply. Okay, so let's take a look at an example here where we can use these concepts. And we're just going to think of marbles here for this example, but if you wanted to think about it in terms of candy or socks or something else, Scrabble tiles, you could. But here we have a bag that contains 4 red marbles, 5 green marbles, and 2 blue marbles. Now they're going to tell you that sentence, and that sentence is going to help you get the total. So if you've got 4, and then 5, and then 2, that means you have a total of 11 marbles that are in this bag. So you randomly draw 2 marbles, one at a time. Find the probability that both of the marbles are red. So both times when you draw, you want to find a red marble. Let's just pretend red is your favorite color. But we're going to find the probability if you replace the first marble, and then if you don't replace the first marble. Okay, so remember, when you replace the marble, this is going to be an independent event. Okay, so we're going to say that there are 4 red marbles out of the whole bag. So that's what we want. Remember, when we're dealing with probability here, we want our favorable. So it says find the probability that both of your marbles are red. So there's 4 out of the total, which is 11. So you reach in and you've got a 4 out of 11 chance of choosing a red marble. And whatever color you choose, doesn't matter, you put that marble back in the bag. And then you're going to multiply it by, you still have 4 out of a total of 11. So that same fraction again, because you've put the marble back. And it's 4 again because we're choosing red both times. But if we were choosing a different color the second time, it might be 4 out of 11, and then maybe the second one we wanted to choose blue, so then it would be 2 out of 11. So this second fraction could change depending on the color of the marble that you're trying to select. But now we just multiply across, so we'll get 16 out of 121. So that's your probability. That's pretty low. That's not going to happen very often where you're going to pick two red marbles in a row. Now, it could happen 16 out of 121 times, so not very often, but it could happen. Now, for part B, we're going to find the probability of whether or not both marbles would be red if you didn't replace the first marble. So again, you have a 4 out of 11 chance that that first marble is going to be red, but now you are not replacing it. So this becomes a dependent situation. So we're going to multiply by our other probability, but if you draw a red marble in that first time, you've reduced the number of red marbles in the bag now because you haven't put that red marble back. And you've also reduced the total because you haven't put that red marble back. So if you choose a red one and you hang on to it, then there's only 3 left. There's only 3 red ones left, and there's only 10 left in the whole bag. So if you're choosing the same color, the number is going to reduce in the numerator and the denominator. If you were choosing a red one first and then a green one, it would be 4 out of 11 and then 5 out of 10. The other color might stay the same. But since we're choosing 2 reds, we're going to reduce that numerator and the denominator. And then we'll multiply across and reduce. So when you multiply and then you reduce here, you end up getting 6 out of 55. Okay, and we have one last example here. And this is a bit more of a word problem, a story problem. So here you're riding a city bus to work, and the express bus arrives between 7:30 and 7:36, and the local bus arrives between 7:30 and 7:40. You get to the bus stop at 7:33. So what's the probability that you have missed both buses? Now, the best way to really visualize this is to draw a picture. So I'm going to draw a little timeline here, kind of like a little number line. And I'm going to start it at 7:30, and then I'm going to end it at 7:40. Okay, the first bus arrives at 7:30 or 7:36, somewhere in between there. The other bus comes between 7:30 and 7:40. So the most I'm going to be there is between 7:30 to 7:40. So I'm going to have my 10 minutes in here. 31, 32, 33, 34, 35, 36, 37, 38, 39, and 40. So let me just kind of label these a little bit. That'll be 7:32, 34, 36, and 38. Okay, so those are my 10 minutes on my timeline here. Now, the express bus, let's choose a color for that. Let's choose blue. The express bus arrives somewhere between 7:30 and 7:36. So somewhere in between there. The local bus can come between 7:30 or 7:40, so all the way to the end. You arrive at 7:33. So here's 7:33. That's you when you show up at the bus stop. Okay? Now they want to find the probability that you've missed both buses. So if you get to the bus stop, there's a 1, 2, 3 minute chance that you have missed the express bus out of the 6 total minutes that the bus could arrive. So the probability that you've missed it is the 3 out of the 6. And then for the local bus, same thing. If you get there at 7:33, there's a 3 minute chance that you've missed it, but it has a 10-minute window altogether. So you're going to take the probability of your first event times the probability of your second event and multiply them together. So you'll get 9 out of 60, and then we have to reduce that all the way down to 3 out of 20. So there's a 3 out of 20 chance that you've missed both buses. So that's small. So that means that you probably will be able to catch either one of the buses still. You have a good chance. You have a bigger chance of catching the bus than you did of missing it. Okay, so when you're going through these homework problems on the worksheet, just ask yourself, are they independent events? Are they dependent events? And you can even label them like I did on the problems. You can put I for independent or D for dependent. And then think if they're mutually exclusive or overlapping. And you can put ME for mutually exclusive and an O for overlapping. So that's a good way to help identify what type of problem you're working through so that way you know what formula to use. And again, we can put these formulas on your little sheet that you get to have on your quizzes for this chapter. And again, if you have any questions, come on and see me before school.